Hello everyone. This video is about Hadoop architecture. I am Mrs. Kavita S. working as Assistant Professor in the Department of Computer Engineering of MIT Academy of Engineering. Hadoop. What is Hadoop? Hadoop is an Apache open source framework written in Java that allows distributed processing of large datasets across clusters of computers using simple programming models. Hadoop is designed to scale up from single server to thousands of machines, each offering local computation and storage. In short, Hadoop is used to develop applications that could perform complete statistical analysis on huge amounts of data. Hadoop runs applications using the MapReduce algorithm where the data is processed in parallel with others. Hadoop architecture. Hadoop framework consists of MapReduce for distributed computation, HDFS for distributed storage, Yarn framework and common utilities. We will see each of these in the subsequent slides. Hadoop architecture. Hadoop framework includes following four modules. Hadoop command. These are Java libraries and utilities required by other Hadoop modules. These libraries provides file system and OS level abstractions and contains the necessary Java files and scripts required to start Hadoop. Hadoop Yarn. This is a framework for job scheduling and cluster resource management. Hadoop Distributed File System HDFS. It is a distributed file system that provides high throughput access to application data. Then Hadoop MapReduce. This is Yarn based system for parallel processing of large data sets. MapReduce. MapReduce paradigm provides the means to break a large task into smaller tasks, run the task in parallel, and consolidate the outputs of the individual tasks into the final output. As its name implies, MapReduce consists of two basic parts, a map step and a reduce step, which are detailed as follows. Map applies an operation to a piece of data and map provides some intermediate output. Then reduce. Reduce consolidates the intermediate outputs from the map steps and it provides the final output. MapReduce. Each step uses key value pairs denoted as key, value as input and output. It is useful to think of the key value pairs as a simple ordered pair. However, the pairs can take fairly complex forms. For example, the key could be a file name and the value could be the entire contents of the file. Example problem, counting words. Assume that we have a huge text document and count the number of times each distinct word appears in the file. Sample application for the same would be analyzing web server logs to find popular URLs. So for the word counting problem, there can be two cases. Case 1, file is too large for the memory but all word count pairs fit in the memory. So you can generate a big string array or you can create a hash table. The second case would be all word count pairs do not fit in the memory but fit into the disk. A possible approach would be write computer functions or programs for each step, that is, break the text document into the sequence of words, sort the words, this will bring the same words together, and third step would be count the frequencies in a single pass. So case 2 captures the essence of MapReduce. So for the word count problem, initially we have to get the words, that is the data file, then sort it and then count it. So on MapReduce it would be mapping, that is extract something we are caring about. That is, in this example it will be the words and the count. Then comes grouping the words and shuffle. And finally reduce the words, that is reduction includes aggregation, summarization, etc. and finally save the results. So the word count problem is picturized in this slide. That is, input, consider two sentences for the input. This is a simplified example. So consider two sentences for the input. The sentences are, this is an apple and apple is red in color. Split the input. into two sentences. This is an apple and second one would be apple is red in color. Then apply the map. That is, this is occurrence is once, is occurrence 1 and occurrence is 1 and apple occurrence is 1 for the first sentence. Then for the second sentence, apple is red in and color. For all these words, occurrences would be 1. Then after mapping, the next step would be shuffling. That is, similar words are grouped together. That is, this occurrence will be 1 and is. Is occurring in the first sentence as well as in the second sentence. So the word is grouped together. Then an occurrence is only 1. Then the word apple. Apple occurs in the first sentence as well as in the second sentence. So the word apple is grouped together. Similarly, red in and color occurrence is only 1. Then after shuffling, the next step is reducing. That is, this occurrence is only 1. For is occurring 2 times. So is written with the value 2. Similarly, an occurrence is only 1 and for apple there are 2 occurrences, and for red in and color occurrence is only 1. And from the reducing step, the output is this occurrence is 1, is occurrence 2 and 1, apple occurrence is 2, red is 1, in is 1 and color is 1. So MapReduce has the advantage of being able to distribute the workload over a cluster of computers and run the tasks in parallel. Executing a MapReduce job requires the management and coordination of several activities. MapReduce jobs need to be scheduled based on the system's workload. Then jobs needs to be monitored and managed to ensure that they encountered errors. Jobs need to be monitored and managed to ensure that any encountered errors are properly handled so that the job continues to execute if the system partially fails. Input data needs to be spread across the cluster. Map step processing of the input needs to be conducted across the distributed system, preferably on the same machines where the data resides. Then intermediate outputs from the numerous map steps need to be collected and provided to the proper machines for the reduced step execution. Final output needs to be made available for use by another user, another application, or perhaps another MapReduce job. The next component of Hadoop is Hadoop Distributed File System, HDFS. HDFS is based on the Google file system and provides a distributed file system that is designed to run on commodity hardware. It has many similarities with existing distributed file systems. However, the differences from other distributed file systems are significant. It is highly fault tolerant and is designed to be deployed on low-cost hardware. It provides high throughput access to application data and is suitable for applications having large data sets. How does Hadoop work? Hadoop runs code across cluster of computers. This process includes the following core tasks that Hadoop performs. Data is initially divided into directories and files. Files are divided into uniform sized blocks of 128 M and 64 M, preferably 128 M. These files are then distributed across various cluster nodes for further processing. HDFS, being on top of the local file system, supervises the processing. How does Hadoop work? Blocks are replicated for handling hardware failure. Generally, 3 replicas will be there. Checking that the code was executed successfully, performing the sort that takes place between the map and reduce stages, sending the sorted data to a certain computer, and writing the debugging logs for each job. Features of HDFS. It is suitable for the distributed storage and processing. Hadoop provides a command interface to interact with HDFS. The built-in servers of name node and data node help users to easily check the status of cluster, streaming access to file system data, and HDFS provides file permissions and authentication. Name node. The system having the name node acts as the master server and it does the following tasks. Manages the file system namespace, regulates the client's access to files. It also executes file system operations such as renaming, closing, opening files and directories, keep the track where this various blocks of data file is stored. Data node. These nodes manage the data storage of their system. Data nodes perform read-write operations on the file system as per client request. They also perform operations such as block creation, deletion, and replication according to the instructions of the name node. Each data node periodically build a report about the block stored on the data node and send report to the name node. Schematically, HDFS is shown here. That is, there is a master node, then 8 worker nodes across 2 racks are there. And there is a secondary node. Already the functions of name node, secondary node and data node are explained in the previous slides. Then the process. If a client application wants to access a particular file stored in HDFS, the application contacts the name node. Then name node provides the application with the locations of the various blocks for that file. The application then communicates with the appropriate data nodes to access the file. Name node limitation. For performance reasons, the name node resides in a machine's memory. Name node is critical to the operations of HDFS. Any unavailability or corruption of the name node results in a data unavailability event order on the cluster. Name node is viewed as a single point failure in the Hadoop environment. Name node is typically run on a dedicated machine. Secondary name node. It provides the capability to perform some of the name node tasks to reduce the load on the name node, updating the file system image with the contents of the file system edit logs. Secondary name node is not a backup or redundant name node. Then HDFS high availability feature. This feature enables the use of 2 name nodes, one in the active state and another in a standby state. If an active name node fails, the standby name node takes over. When using the HDFS high availability feature, a secondary name node is unnecessary. Then the next component in Hadoop architecture is YARN. YARN stands for yet another resource negotiator. YARN separates the resource management of the cluster from the scheduling and monitoring of jobs running on the cluster. YARN replaces the functionality previously provided by the job tracker and task tracker daemons. Let us discuss the job tracker and task trackers. Hadoop with the job tracker and task tracker is shown here. High level Hadoop architecture, then task tracker is there, job tracker is there, then name node, data node. The functionalities of job tracker and task tracker. Primary function of the job tracker is resource management, tracking resource availability and task lifecycle management. The task tracker has a simple function of following the orders of the job tracker and updating the job tracker with its progress status periodically. The task tracker is pre-configured with a number of slots indicating the number of tasks it can accept. When the job tracker tries to schedule a task, it looks for an empty slot in the task tracker running on the same server which hosts the data node where the data for that task resides. If not found, it looks for the machine in the same rack. There is no consideration of system load during this allocation. LinkedIn. LinkedIn is an online professional network of 250 million users in 200 countries as of early 2014. LinkedIn provides several free and subscription-based services such as company information pages, job postings, talent searches, etc. So LinkedIn utilizes Hadoop for the following purposes. Process daily production database transaction logs, examine the user's activities such as views and clicks, feed the extracted data back to the production systems, restructure the data to add to an analytical database, and develop and test analytical models. Yahoo. As of 2012, Yahoo has one of the largest publicly announced Hadoop deployments at 42,000 nodes across several clusters utilizing 350 petabytes of raw storage. Yahoo's Hadoop applications include the following: search index creation and maintenance, web page content optimization, web ad placement optimization, spam filters, ad hoc analysis, and analytical model development. The references used for the video are from Hadoop Dataflyer and Introduction to MapReduce from GeoPike. Thank you.